Hello, Audrey. So today we're going to continue with the lesson that we have had. Okay, the last meeting we have done question number 1, which is the case when an antiderivative is 0. Okay, if an antiderivative, if derivative of a certain level is 0, means that we can find the original function by doing multiple integration. Okay. This will result in a polynomial with the degree of n minus 1, with the n being the first level of differentiation that the result is 0. So let's say if you have y4 is 0, then y is going to be a polynomial for with the power of 3. So it's going to be ax cubed plus bx squared plus cx plus d, etc. Okay. If the nth level of polynomial is a constant, okay, let's say y5 is a constant, let's say 7, for example, then we know that it's going to be polynomial of the same level. So y is going to be a5, sorry, it's going to be polynomial to the power of 5. So it's going to be x power 5 with the coefficient of the highest number, that's going to be 7 plus some number, x power 4 plus c3, x power 3 plus c4, x power 2, etc., etc. Okay. Those are the case when we have only a single derivatives, and the result is either 0 or a constant. Now we're going to continue here with the concept of polynomial when we can simplify it. This polynomial on a first see, it looks like it is going to be polynomial of an order 2, but with very simple substitution, we can change this into a polynomial of order 1, which we already know how to solve. Okay, here's how we do it. Y double dash minus y dash is 0. Okay, and we know besides that y2 and y dash 2 is 1. Okay, now to solve this here, take a look that this doesn't have any initial y, only the first and second derivatives. So we can simplify this by making the first derivative as another function. Let's call this function g, for example. So g, the letter g looks like the number 9 here. I'm going to take another letter here. Let's say I'm going to call them h. H of x is the same with the y dash of x. Hence, the first derivative of x is going to be the second derivative of y with respect to x. And okay, y dash of 2 means h of 2. Now, with this information, we can write this as h dash minus h equals 0, with h2 being 1. We already know how to solve this type of questions. It is going to be, think of this like hx minus kh equals 0, and the answer is h is going to be a e to the power of the negative of this. So it's going to be kx. Why? Because if we put them here, h dash is going to be ka times e to the power of kx. And if we substitute h dash minus kh is becoming ka e to the power of kx minus k of a times e to the power of kx, which is simply 0, which is correct. Okay. Now that we have them here, okay, we can then find out the value of h2 here. We can find out the value of a by finding the number of h of 2. Oh, by the way, k in this case is -1. Hence, h of x is a e to the power of x. Just that. Okay. In this case here, the negative of k is negative of 1 here. The k is just 1 here. K is 1, so hx is a to the power of x. Now, how to find a? We substitute here. Substitute that h of 2 is 1. Hence, 1 h2 is a times e to the power of 2. Okay, that is going to be 1. So a is 1 over e squared, or it's e to the power of -2. Taken together, we'll say that h is e power -2 e power x, or we can simplify as e to the power of x -2. This is just h. This is not yet the y. Okay, so remember here we have y dash of x is e to the power of x -2. Now, with this in mind, we can find out the y dash. Sorry, we can find out what is the y itself. In this case, finding the y, we'll just need a simple integration. I'm going to erase everything now. This is what we had now. That y dash x is e to the power of x -2. And we know that y of 2 is also 1. So how do we find the y? We are going to integrate. So y is going to be integration of y dash dx. It's going to be the integration of e to the power of x -2 dx. Okay, now I think this is an easy thing for us to do. Okay, it's going to be the same here. It's going to be e to the power of -2 plus c. That's y of x. Okay, and to find the constant c, we do it by substituting this value. So y of 2 is going to be e to the power of 2 minus 2 plus c. The value is 1. Okay. E to the power of 0 is 1. So c must be 0. I think in this case, we can put them C number 2 here. So the y, put this back into this equation, we conclude that y of x is just e to the power of x minus 2. That's it. This is the result, and we know this by doing the second differentiation. The key trick of this type of problem is check if there is no original y, just the derivatives of them. We can often simplify the question by substituting the y dash as the new level of variable, dependent variable. Let's say if you have y3 minus some number of y double dash, plus another number of y dash equals to 0. But there is no y itself, just y, just the derivatives. In this case, it is a good idea to simplify by taking the lowest level of derivatives as a new function. Let's call y dash as, in our case, h. So this becomes h double dash minus k h dash plus k2 dash is 0. We simplify from a third order into second order. And then we can solve them. So this is how we do it. After getting the h here, we can find y by integrating the h itself. So h is going to help us before we do the last mile doing the integration. I think that is it for this explanation. Okay, that's the end of question number 2. Thank you.